Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. This is the first video, guys, where I'm tackling questions from the 2024 May-June Mathematics Paper 1 examination. Please do expect a total number of 11 videos because each and every question will have their own video. And guys, I'm answering this question because I want you to have an edge for your upcoming exam, né? So please do share the video to your peers so that they may have the same edge as well. Okay, question 1. We are being asked to solve for x. Whenever, guys, you're solving x, there are certain steps that we need to follow. Firstly, we must make sure that you don't have fractions, surds, or brackets. If you don't have those three, then we move to the second step. Just make sure that your equation is in standard form. If your equation is already in standard form, move to the next step. Make sure that the value of a is positive. Yes, 3 is positive, and if it's possible, make it to be equals to 1. If we divide every term by 3, we'll end up having fractions, and we don't want to have fractions whenever we solve x. So we'll just leave it like this, nah? Then the next step, we just need to factorize. So since I don't have a constant term, it's quite easy for me to factorize because I'll simply take out the common factor. If I have 3x squared plus 5x being equals to x, my common factor between the two terms over there is just x. Whenever I take out x as my common factor, I'll be left with 3x plus 5. And then now I have two things that are multiplied and the answer is 0. That simply means that either the first thing is the one which is equal to 0, or the other one is the one that is equal to 0. And then already here I have isolated x. Now I just need to isolate x on this other equation. I'll have 3x is equal to a negative 5, then x is just equal to negative 5 over 3. So therefore, the solutions over here, x is equal to 0 or x is equal to negative 5 over 3. Okay, for the second question, we are being asked to solve for x again, but now they told us that we must leave our answers rounded off into 2 decimal places. Once you see this statement, guys, please always know that you don't have to factorize. Are you together? You don't have to factorize. You just have to use your quadratic equation. Your quadratic equation simply says x is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. Remember that, guys, a is anything in front of x squared, that's 4. B is anything in front of x, that's a positive 3. And then c is any term that does not have x. So that is just negative 5. Are you together? Then all I have to do is to just substitute over there. X is just equals to negative b plus or minus b squared minus 4ac all over 2a. I'll just punch my precious calculator. Negative 3 plus the square roots of 3 squared minus 4 ac all over 2a. What's going on now? Okay, whenever I start by using the plus over there, I'll simply get an answer of 0.804. That's 0.0. That's 0.80. And then whenever I use the minus sign over there, I'll simply get negative 1.55. So x is just 0.80 or x is equals to negative 1.55. Okay, and then for the following question, I'm supposed to solve x whenever I'm given an inequality. Remember that, guys, an inequality is not like an equation. Yes, the steps are similar. However, the final answer should differ, because with inequalities, you are not looking for an absolute answer. Are you together? We are just looking for a group of roots or a group of solutions that will accommodate that statement over there. Okay, So the steps are the same, guys. If we have brackets, we must just remove our brackets. If we have sets, we must remove the sets. If you have fractions, we must also remove the fractions there. Okay, you can easily open two brackets over there, and then you'll end up having x squared minus 2x plus 1, and I still have my negative 9 over there. That's greater or equals to 0. And then x squared minus 2x minus 8 is greater or equals to 0. Now my expression on the left hand side is in standard form, and I don't have brackets, fractions, and set, and the value of a is positive, and yes, it is equal to 1. So it will be quite easier for us to factorize. I'm looking for the factors of 8 that when I subtract will give me 2. The factors of 8 that when I subtract will give me 2. That's 4 and 2. And then the bigger sign will always take the sign of the middle term. Are you together? Whenever my constant term is negative, my two brackets will have different signs, but the bigger factor will always take the sign of the middle term. So I'll have a minus over there, and then I'll have a plus over there. After factorizing, guys, we then need to write down our critical values. Critical values are the values of x that when you substitute over there will give us 0. Are you together? So I know that whenever I substitute x as 4 on my first bracket, I'll simply have 4 minus 4, and that will give me 0. Another one, whenever I substitute x as negative 2 on my second bracket, I'll simply have negative 2 plus 2, and that will be 0. After finding out my critical values, I just need to write them down on the number line. I have negative 2 and 4. The sign over there, guys, says it's greater or equals to. Are you together? Firstly, I know that my critical values should be included since I have an equal sign over there. Ne? Should be included. And then the numbers in front of x inside the two brackets over there. The numbers in front of x inside the two brackets over there, both of them are positive because I have positive 1 in both of them. Ne? So since they have the same sign, they can be both positive or they can be both negative, the coefficients of x after factorizing. If they have the same sign, that means I'll start with a plus here. After finding this sign, I don't have to worry about what to put over there, because I know that the signs will just keep on alternating. If I start with a plus, I'll follow with a minus as well as a plus. Are you together? I'm looking for the values of x that will give me something that is greater than 0. Are you together? Greater than 0 simply means positive. Are you together? So I can see positive from negative 2 going to the left. So how do I write that solution? I'll simply say when x is less or equals to negative 2, and then I also see a positive from positive 4 going to the left, and then I'll simply say or when x is greater or equals to 4. That's how, guys, we deal with inequalities now. Okay, and then now I'm supposed to solve x when x is at the exponent. I have 5 to the power 2x minus 5 to the x is equals to 0. Yes, there are many ways, guys, of doing this. You can take out a common factor, but I prefer using a K method. Ne? Once I see a plus or a minus separating terms, whenever I'm solving x and my x is at the exponent, I just need to take out I just need to use the K method. Are you together? So I'll simply say let 5 to the power x to be equals to k. So since over there I have 5 to the power 2x, that means that term will simply be k squared minus k is equals to 0. Then I can just take out a common factor. K minus 1 is equals to 0. Then k is 0 or k is just equals to 1. But we were not solving for k. K is just a tool that will help us to find the solution quite easy. So I'll just continue over there. Whenever I come across k, I'll substitute 5 to the power x back. This would give me 5 to the power x equals to 0, or 5 to the power x to be equals to 1. There is no solution over there, guys. Né? There's no value of x that I'll substitute at the exponent and get an answer of 0. So that's why there is no solution. That's why there's no solution. No solulu. And then over here, we can make the basis to be the same, because I know that any number raised to the power of 0, is equals to 1. So 5 to the power of 0 is equal to 1. Now I do have my basis to be the same, and therefore x is just equal to 0. X is just equals to 0. Okay, and then now all I have to do is to solve x on 1.1.5. If I'm told that let me erase even here. I'm solving x and my equation has both fractions and sets. So this equation has many wrong things that needs to be removed. That's x all over 20, the square root of 20 minus x being equals to 1. Né? Firstly, I can remove the fractions over there by just you can say cross multiplying, or just multiply each and every term by the LCD. You'll simply have x being equals to the square roots of 20 minus x. But now yes, the fractions are gone, but now I need to remove the sets. I can do so by just squaring both sides, and then I'll be left with x squared is equals to 20 minus x. Then obviously now that I don't have sets, I don't have brackets, and I don't have fractions, the next step should be make sure that your equation is in standard form. Standard form simply means everything is on the left hand side and there's 0 on the right hand side. Né? So this will give me x squared plus x minus 20 is equal to 0. So I'm looking for the factors of x, of 20 rather. That's when I subtract, will give me 1. Né? So that's x and x over there. The factors of 20, that's when I subtract, will give me 1. That's basically 5 and 4. The bigger factor will simply take the sign of the middle term. 5 is bigger than 4, so the sign of the middle term will come over there, and then the opposite sign will go there, and then x is basically equals to -5, or x is equals to 4. Are you together? Whenever, guys, you have sets, you must go and check whether your solution is valued or not. Né? You can simply go to your original equation and substitute these values of x, both of them. Are you together? If you find that the left hand side is not equal to the right hand side, that means that solution is not applicable. But if you substitute and then you find that the left hand side is equal to the right hand side, it simply means that your solution is applicable. So I know that in this case, -5 will not be applicable. That means x is equals to 4 only. Are you together? X is just equals to 4 only. Okay, and then now I need to solve for x and y simultaneously. What are we given? We are told that equation 1 has x plus y equal to 9. That's our first equation. And then I have 2x squared minus y squared is equal to 7. That's equation 2. Né? Okay, we must always try and manipulate the easiest equation. The easiest equation, guys, is the first one. Né? We can simply say that from equation 1, y is equal to 9 minus x. By doing this, we are forming equation 3. Né? Since we used equation 1 to form equation 3, we cannot say substitute equation 3 in equation 1. Why? Because we derived equation 3 from equation 1. So we just need to substitute equation 3 on the other equation. All together. We'll end up having 2x squared minus y squared. Remember that y is basically equals to 9 minus x. Y is equals to 9 minus x, but it's squared. Then I have 7 on the left hand side. All I have to do now is to remove the brackets. I have 2x squared. Yes, we'll open two brackets and then multiply out by this negative over there. You'll end up having negative 81 plus 18x minus x squared is equals to 7. Are we together? And then I simply have 2x squared minus x squared. That's basically x squared plus 18x, and then I have negative 81 is equal to 7. Now all I have to do is to make sure my equation is in standard form. Excuse me. That's x squared plus 18x minus 88 is equals to 0. I'm looking for the factors of 88. That's when I subtract will give me 18. Factors of 88. Let me check. 88 equals to shift fact. That's when I subtract will give me 18. Oh, that will be 22 minus 4. Yeah. So I have x and x, 22 and 4. Since my constant term is negative, the brackets will have different signs, and then the bigger factors should just take the sign of the middle term. I have a plus and a minus over there, né? And then x is basically equal to negative 22, y is equals to a positive 4. After finding both x and y, I can simply go back and find the corresponding y values. I'll say when x is equals to negative 22, therefore y will be simply 9 minus x. Same thing applies over there. When x is equals to 4, therefore y will simply be 9 minus x. That's negative 22 as well as 4, né? So 9 minus a negative 22, this will give us y to be equal to 31, and then over there y will simply be equals to 13. So whenever I write my solution, guys, I'll write it as coordinates. I know that when x is negative 22, its corresponding y value will be 31, and when x is equals to 4, its corresponding y value will simply be 13. That's how you're supposed to solve that simultaneous equation over there. And then now we are left with we are left with determining the products of p and t for us to get full marks in question 1. Yes, guys, I truly believe that if you can get this the last question on question 1 correctly, you have a greater chance of getting 100% for your paper 1. If you get 1.3 correctly, you have a greater chance of getting full marks on paper 1, and on paper 2, if you get the last question on question 3 correct, you have a chance of getting full marks on paper 2 as well. Okay, what are they saying? They want us to find the products of p and t. What are we given? Okay, we are told that we are told to multiply p and t, but p is just 1 minus a, and then t is a product on its own. That's 1 plus a squared, 1 plus a to the power 4. It continues until 1 plus a to the power 512. So they want us to find the product of P and T in terms of A. Now, if you can check there, guys, the first two terms, this is just a factorized version of a difference of two squares. You can see that. So the first two brackets will simply give us 1 minus a squared, because I know that whenever I factorize 1 minus a squared, this will give me these two brackets. Are you together? But I still have the product. That's 1 plus a squared, 1 plus a to the power 4. It continues until 1 plus a to the power 512. But guys, please check here over again. This is just a factorized version of a difference of two squares. And that will give me 1 minus a to the power 4. I know that whenever I factorize these, it will give me those two. Are you together? And then I still have my product. That's 1 plus a to the power 4. And then the next brackets would have been 1 plus a to the power 8. How do I know? Because these exponents of t, the exponent of t, right, for a, they are in a quadratic sequence. Ne? This is 2 times this one. 4 is 2 times 2. That means the next exponent was going to be 2 times 4. It would have gone. It would have continued like that until it reached 512. Are you together? So this will go until a plus 512. But guys, check this. These two, a factorized version of a difference of two squares. So this thing, guys, will keep on happening. A to the power 8. Why did I say plus? Whenever I factorize these two, I'll simply get these two brackets over there. Are you together? And then, yes, I still have my a to the power 8 until 1 plus a to the power 512. These two brackets will give me a minus a to 1 minus a to the power 16. This will go until 1 plus a to the power 512. Ne? We can see that, guys, this thing will keep on going on and on and on until we have 1 minus a to the power 512 multiplied by the other bracket, 1 plus a to the power 512. And then this will end up giving us 1 minus a to the power 1024. So the product will just give us p multiplied by t will just give us 1 minus a to the power 1024. Yeah, because I know that whenever I factorize this 1 to the power 1024, I'll simply get these two brackets. So that's how, guys, we're supposed to deal with question 1. I really hope the video helped you out. So just stay tuned and wait for more videos. Thank you.